before we start putting ideas on the board, how are we going to organize our ideas about that question? What are the characteristics of solids, liquids, and gases?
Chart. What I'm saying. Simply what?
Okay. What's the chart? What do you mean? Like, you're going to have to give me a little bit more detail. Sorry.
Like you'll have 3 columns, and one has solid, one has liquid, and one has gas. Make sure you have lines in between. I'm pretty sure it's in my.
What'd you say?
So make sure you have lines in between you separate. Lines.
It's easy to read.
Mine remember the words.
Yeah, my organization.
Okay. So that seems like a pretty useful way to organize our ideas. So let's fill out this chart.
Liquids can turn into gases.
How do you want me to put that on here?
Turn into liquid.
Or solid.
What?
And it can also turn into a solid.
They can all turn into each other.
Yeah.
Okay. Now, how is what they can turn into different than a characteristic?
It's what it looks like.
Say that again here.
It's what it looks like.
Okay. So then, what could we put on here, considering what you needed to say?
The particles of liquids are loose and live together, kind of like water.
What do you mean by loose?
They're not as spread out as like gases. Because gas is in the air, so it's pretty spread out. But it's not as solid as. It's not as dense as a solid because solids they're like coming together and in liquids they can flow and move around.
Okay. What else should I put up? I mean, we should be able to. The solids, liquid, and gas is a pretty normal
Aren't they like
thing.
great stuff? Gas would be least dense.
Keep going, people. Like this should go faster. Let's go.
Solid is something you can like hold without it being like a container.
Without a what?
Being in like a container.
Solid has more compact particles.
Sometimes you can see gas and sometimes you can't.
God, it's good.
This is one of those things that every single person can engage with. I refuse to let 4 people contribute to this list. Let's go, people. If you were describing a liquid or describing a solid, what would you say?
Solid's hard.
Liquids can't hold shape.
Liquids are mostly wet.
Say again.
Liquids are mostly wet.
They're running. can't hold the shape of it.
Jeremy.
With that being said, solids obviously can hold shape. Good. I said one thing. Never.
This in here, solid or liquid, solid, gas. What's the difference between those three things? Oh,
You can't see. Yeah.
Sorry, okay.
oh, we have can't always see, so
You can sometimes see that.
that's why it says can't always see. Charles,
They all have different density.
they all have different what?
Density.
Okay. So we have up here we have least dense. So what can we put in these two?
More dense.
You
Dense
don't
is
ignore.
Okay. So most dense. And then what should I put here?
between.
Dense.
Just put dense light.
Dense.
Thanks.
Can I raise my hand yet?
Go ahead.
Okay. For liquid, it only takes the shape of whatever container it's in.
What does that mean?
Like if you put it in a square container, it'll turn into a square. If you put it in a circle container, it'll turn into a circle. Put a triangle. Yeah. You get that?
How is that different than a gas?
The gas will go out.
Because if you put compressed air into a pig, it will just sit there and it will be in
Into a what?
pig.
A pig?
Yeah.
Like the animal?
No,
No.
the gas container.
Oh,
Wow.
you mean the like the propane tanks, things like that.
I'm talking about compressed air.
Yeah. Okay. I was like, what are you putting compressed air into a pig for?
Pig.
All right. So okay, so like you're those oval containers that you see on farms most of the time, and I don't think they have them in South Sioux very often. Those it'll take the shape of that thing. What if you put a liquid into that thing?
Gas. might
Put
turn-
air that's compressed.
He said, what if?
Yeah, I'm asking what if you put a liquid in
Well,
there?
he's taking that over here.
Design.
Like so, we'll draw the container.
Do we have to grab it?
No. If I put gas in this container, where does the gas go?
Into wherever you put it.
I'm telling you, I'm putting it into this container.
But if you have to do something
Where does it go?
in there,
It stays
I'm
in.
gonna close the container behind it. Like I'm gonna put a tube in there, and then I'm gonna pump gas in, and then I'm gonna shut it off.
That's when it stays there.
Okay, but
it
what part of the
expands in
container
there.
is it in?
It's bound in there. It can't expand anywhere else.
Looks like a potato with ears.
So where's the gas at in this container?
Inside the walls.
How much of the container?
All of it.
Oh, if I put a liquid in here. Now let's say I only fill it quote unquote half full of gas. Where's the gas at in here?
On top.
Over there.
Gas is everywhere. If I fill it half full with liquid, where's it at?
On the bottom.
Okay? And so how can we use what it kind of looks like a hot dog now. How can we use this difference that water goes on the bottom and gas fills the whole thing to help us tell the difference between gas and liquid?
Because it can expand.
float on top of water.